Today we're going to focus on equivalent ratios. If you remember from yesterday, a ratio is a comparison of two numbers using division. What's equivalent mean? Equal or the same, right? So this is going to be a way of making ratios equal or the same to each other. Oops. So on your sheet there, we have ratios that are equivalent can be simplified to the same ratio, just like an equivalent fraction. So if two ratios are equivalent, they can both be simplified to the same thing. And that's one of the ways we can compare these and make it a little easier. And then a little bit below that, the scale or factor in which both numbers in the ratio are multiplied to form an equivalent ratio. So the scale or the factor, that's what's used to multiply the ratios. They generally show it with multiplication only. You can think of it as multiplication or division. So really the concept is you're just making things equal. It's not too tough to do. I'm not going to do the first one for right now because it can only go bigger. So if we look at number 2 here, I got a ratio of 18 to 12. Okay? We can make equivalent ratios by either making them bigger or smaller. If you're going to make them smaller, you divide. So with each of those ratios, you got 18 and 12. 6 goes into both those, right? So if I divide by 6, I have a ratio of 3 to 2. You can also make ratios bigger by multiplying by anything. So if I multiply each of those by 2, 18 times 2 is 36, 12 times 2 is 24. All 3 of those ratios are equal to each other. So 18 to 12, 3 to 2, and 36 to 24 all are equivalent ratios. If I simplify them, all 3 of them would simplify to 3 to 2. All right, 3 to 11 here, you can only make it bigger. Nothing goes into both 3 and 11. So we can't simplify it any further. We can only multiply to make it bigger. So Chastity, give me a number. 3. 3 times 3 is 9. 11 times 3, 33. Alexandra, give me a number. 4. 3 times 4 is 12. 11 times 4, 44. I'm glad y'all did not pick big numbers. That would have been a little tougher. All right, y'all try 6 to 10. Get 2 more ratios that are equal to it. There's basically pretty close to an infinite amount of possibilities. Robert, give me one. 3 to 5, that works. You simplified. They simplified to 3 to 5. Sydney? 12 to 20 is correct. That'll work. In that case, she multiplied by 2. All right. Like I said, there's like an infinite amount of possible answers. We could multiply by anything. You can even multiply by things that aren't whole numbers to make them equivalent. All right, so if I do times 2.5, 6 times 2.5 is 15. 10 times 2.5 is 25. That would still be equivalent. It doesn't have to be whole numbers, okay? There are 2 ways you can see if ratios are equivalent, or two main ways. The first way is you can cross multiply. If they're set up like a fraction, you can cross multiply. So we're multiplying across like that. What's 2 times 20? 40. What's 5 times 8? So are those equivalent? Yeah, we got the same thing. So the number 4 there would be a yes. And in this case, it's asking what you multiply by to go from the left to the right. So to go from left to right, we're multiplying by 4. The other way you can check to see if they are equivalent is by putting them into the calculator. Okay? So, get your calculator. Click that BC button to put in a fraction, and then put 12 over 4 and hit enter. That gives you 3, right? When we get a whole number, remember what do we do with it then? Put it over 1. So we got 3 over 1. There's 1. We do the same thing with the other one. So we got 6 over 3. And we get 2 over 1. Are those equivalent then? No. If they were equivalent, they would simplify to the same thing. All right, so check number 6 there. 8 over 6 and 20 over 15. See if those are equivalent. You can do it either way. Gray? Yeah, they are both equivalent. So that's a yes. If you cross multiply, 8 times 15 is 120, 6 times 20, also 120. If you simplify, both of those simplify to 4/3. If we go by what you're multiplying, if you try to find what you're multiplying, in this case, it's a multiplying by 2.5 or 2.5. 2.5 times 8 is 20. 6 times 2.5 is 15. So, any questions on that? Like I said, those are the two main ways. There's other ways you can check to see if they're equivalent in terms of working it out. That's probably the easiest two ways. If it's calculator active and you need to see if it's equivalent, obviously just simplify with the calculator. If it's inactive, cross multiplying is probably going to be the easiest. All right, flip that over. So we got 8, 9, 10, 11. We're skipping a couple things. We'll skip down to those. For number 8 there, because I know the copier didn't exactly do a great job with the gray squares. If you look at the board, how many gray squares do I have? 4. Kind of shade them in on your paper. Because like I said, I know they didn't show up. So, you know, we got right there and there. So if I've got 4 gray, how many white squares I got? There's a ratio, right? 4 gray for every 3 white, or 4 to 3 for the gray to white. It's asking me how many gray squares we would have if we had 15 white squares. So we just fill in the blank on the other side, 15 white. There's a reason I label these. It makes it easier to match them, okay? We want gray on top, both sides, white on the bottom. Could I have it flipped over and have white on top, gray on the bottom? Yeah, as long as both sides match. If I would have done 3 and 15 on the top, 4 and the blank on the bottom, it still works. It's just we want both sides to match each time. All right, so what do I multiply by to go from 3 to 15? 5. So we got to do the same thing to the top. 4 times 5? 20 gray squares. So that would be our answer right there. Any questions on that? All right, y'all try the other 3 there. All right, a couple of these are a little trickier. So number 9, Ford.
18 hours.
18 hours. That one, a little more straightforward. We got 9 days or 2 hours paid vacation every 9 days. So if she works 81 days, we're multiplying by 9. That's giving us 18 hours. All right, the other 2 get a little trickier. Anybody think they got the answer for number 10? Jacob? It is 30. Here's why. It gives us a ratio of 5 to 8, right? That is gold rolls to red rolls. Everybody clear on that? So if I do my proportion, I would have 5 gold rolls and 8 red. But then it asks if the school sells 78 rolls. That's total rolls, right? You see how my sides don't match then? So we're going to make the sides match. Instead of 8 red rolls, how many total rolls is that? 13. So now my labels match on each side. Okay? To go from 13 to 78, we're going to multiply by 6. 5 times 6 is 30. So we'd have 30 gold rolls. Okay? Similar idea for number 11. It says there's a total of 30 puzzle pieces. 3 out of every 5 are red. The remainders are black. How many puzzle pieces are black? If you set it up with the ratio they give you, you get 3 to 5 red to black. But that makes it a little tougher. So who thinks they got that? 12 is correct. All right, so if you're looking at it with red to black, it's not going to work. What you want to do is when you set up the proportion, since it's asking you for black, we got to make sure we're using black. So if 3 out of every 5 are red and the remainder is black, how many are black? 2. So we got 2 black. It's out of 5. 5 is the total. And then it gives us the total to make our sides match. If we use red and black, the sides aren't going to match. So to go from 5 to 30 is times 6. So same idea. 2 times 6 is 12. That gives us 12 black pieces. Like I said, those last two, a little bit trickier in how they work. That's the type of stuff we're going to keep getting practice with over the, for sure, rest of the week. Okay? Any questions on those? But really, those problems are about as tough as these get. So if you were able to do those on your own, that's awesome. If you weren't, hopefully you could at least follow along and we'll get more practice.